All right, I've got a whole bunch of slides to get through. People have planes to catch. We've got a demo to attempt. All right, we're going to talk about ADE-bench. Here's a new slide. All right, so real quick, this is Coalesce. Y'all know that. I am Ben. My current affiliation is like exploring something new. So yeah, I don't know what that means. Anyway, we're not going to talk about any of this stuff. I want to start actually here, which is a Financial Times article from about a month ago about why quarterly earnings will go away. The context of this is, as most of you probably know, most companies that are public report their earnings like once a quarter, kind of like 28 days-ish after the end of the quarter. This guy, who I don't know his name, he's the chair of the SEC, was like, we don't need to do that as much. That's too often. Let's do it less. Let's do it like twice a year instead of 4 times a year. And then he posted about it on the internet. Paul Adkins, that's his name. And he posted about it on Squawk Box, and so it was the internet, and it was on Squawk Box. And so naturally, everybody argued about it. Some people were like, let's do it 4 times a year. Let's do it twice a year. Let's do it once a year. Like crypto people were like, never do it. And so the Financial Times was like, no, we don't need to have this debate at all. This whole debate is moot. And why do they say it was moot? They said it was moot because business is shifting their data to using the cloud and artificial intelligence, and we should be able to do this in close to real time. And so they said, no, this isn't enough, not this, not this. We want this. You should do like reporting every day, all the time. And the way they do that is because tech groups such as Palantir, Databricks, and Snowflake, we know those people, already help companies turn disparate records into crunchable digital data for executives to use and peruse. What a fun way to put that. AI agents can sum information and package it and add gloss as well as any silver-tongued chief executive. And so what they're saying basically is if you go to Google Finance beta, there is like a chat-body thing that you can chat about SEC earnings, and they're like, companies should just have this too. So if you were IBM, you would have the same chatbot, or ExxonMobil, or the Tootsie Roll Industries. This is an actual public company. I did not know that. Turns out, yeah. So if you go to one of these companies, they're saying like instead of there being quarterly reports that you file once a quarter, you should be able to like do your financial analysis in real time on top of agents. And so all of us as data people, if we're like asked, what do you think of this? Our response is like, what, us? But we're also like, what the hell are you talking about? Teradata, which is like a thing to do, turn crunchable digital data into assets to use and peruse, has been around since 1979. MicroStrategy, which is like Michael Saylor's thing, has been around since 1989. Google Analytics, which is real time, if you go there, it'll tell you how many people on your website right now, has been around since 2005. The companies that they mentioned in that thing that are like bringing this future to life are Palantir, which has been around actually longer than Google Analytics, Snowflake since 2012, Databricks since 2013, and like, my God, it is 2025. They are basically saying we're going to solve this by putting agents on top of it. What are we talking about? What are we talking about? What are we talking about? And so like, okay, in some ways, this is obviously my reaction. This is like sort of my whole vibe. I get it. And as they say, like, it is not the critic that counts. It is also the people in the arena. That is all of y'all. Thank you very much. But it's also not really y'all that matter. It is like our bosses that count. And so who reads the Financial Times? Well, according to the Financial Times, it is relied upon by leading corporate executives and high net worth individuals and the most influential people in business and politics. 29% of them work for the C-suite. And this is what they believe. And so like in some ways it doesn't matter what we think, and it doesn't matter about how much we think this is all dumb. Because if executives think this and this is what they want, this is what we got to do. And they are getting it in other areas. So we all kind of know these things. But executives of very big companies are saying, hey, AI can write code now. 30% at Microsoft, allegedly. Salesforce says, no, we can do 50%. Google weekly is only doing a quarter. And so like this is sort of possible in other places. And so this is kind of what people are expecting. And so like, hey, we should be able to do this for data stuff. And so how do we do this? There are obviously some folks around here who are trying to solve this. Shout out to the folks at Hex. Anybody can analyze stuff with Hex using a chatbot. Shout out to my former employer, ThoughtSpot. You can do something similar. There are other smaller companies. Julius is one of those. They're like these AI analysts that can solve problems for you with data, to which I say, good luck. We're all counting on you to solve this problem. Thank you very much. But if you go like look at these problems, these things aren't necessarily just coming from like the cursors of the world that are building apps on top of it. The reason those things are being able to be successful and they work and like companies are actually having a lot of success writing code with AI is the foundational model providers are also focused on this. So if you go to like Gemini, this is the thing they say at the very top of their website. It's great for writing code. Like this is how they sell this product. When ChatGPT or OpenAI introduced GPT-5, the very first thing they said that it was good at was coding. When Anthropic released Sonnet 4.5, the very first thing they said is, look at how good is it coding. And so you have to have some attention from these labs as well. Like, we can't just build these apps on top. You also have to be able to say, hey, these are things that matter, and that like the ability to do analytical tasks is important too. And so right now, they tend to be very focused on code. And one of the reasons they're very focused on code is because there are benchmarks for it. This is the Anthropic set of benchmarks that they released, I think, with 4.5. There are several of these are code. There's an analyst one-ish at the bottom that is like financial analysis. It's not like data analysis like people here do. If you look at Google's benchmarks, there is absolutely nothing about data. If you look at OpenAI's benchmarks, there's absolutely nothing about data. And so that's kind of the motivation of this, is like, hey, can we actually provide some things that not only help us understand if these things are better, but are also a resource for people who are building models to be able to say, like, are they getting better at some of these tasks that we are asking them to do? There are some benchmarks out there. People are probably familiar. This is the most notable one, and one that like we have taken some things from and borrowed from. Like, they have really good data sets that's really helpful. This is called Spider. They tend to be very text to SQL oriented, though. They tend to be very much around, here is a question. Can you write a SQL query that actually answers this question? Which aren't the kinds of problems that we tend to focus on. So like, those sorts of benchmarks and a lot of the ones that exist kind of have a world like this, where there's a very simple schema of a handful of tables, and there is a question like, what is the most popular product in California? And you get an answer that's a table or a number or whatever. And like, as we all know, the real world that we're trying to work in looks like this. And the questions that we have are like, what? And so like, this is the problem. And so basically the goal of a lot of this was, can we build a thing that represents something a little bit more like this, that we can then give to both the products that are building things on top, as well as people who are trying to build sort of more foundational models to say, hey, how good are these things at solving these problems? So that's what I'm going to talk about and kind of run through here. The other bit of context for this is, there's a company called Get Macro. These are some former Mode folks. You should check it out. Part of the reason I am here doing this is because they're working on a problem that's similar to this. They're working on a way to build like basically a Claude code for data problems. And they were like, hey, can we add more tests to these benchmarks? We want more tests. I was then talking to some folks at DBT, like Jason Gans, and he was like, can we also add some analytics engineering tasks, because we don't have that? And both of them were like, you're exploring something new. And so here we are. So ADE-bench, that's what we're going to talk about, and that's how we got here. We're going to talk about what it is. We're going to do a quick demo and some very early results, like early. And then if people want to help or be involved or just hang out, cool. OK, what it is. First of all, stylistically, this is not exactly how it works. It's kind of how it works. It's like a simplified version of how it works. You can see the real one in a second, and it's much messier, but this is like the easy version to put on slides. So basically, there is a set of shared DBT projects, things like this, like the Shopify project or a Jaffle Shop project. Apparently, this should be flowers now, I guess. These look like DBT projects. They are all the things we know and expect from a DBT project. There's some models and some like DBT configuration files and packages and all that sort of stuff. The second thing that is in this benchmark is databases. So these are, again, helpfully provided by the Spider folks. DuckDB databases of what is inside of these projects. So in this case, there's like a Jaffle database or a Shopify database or whatever. If you open these up, if you open up the DuckDB database, you get this. I don't know what that is. But if you open it up in like a fancy thing, you get this. So it's a database, cool. And the third thing is there are a set of tasks. And these are like the evaluations that you run to figure out if these things work. And so what's in tasks? You basically have like individual trials to test the things. And so these will have a task configuration file that defines like what problem we're trying to solve. The very core of that is it says, hey, the Jaffle 001 task is trying to solve like a problem in the DBT project called Jaffle on top of the database called Jaffle. Great, that all makes sense. These things match. Look at that. And then there is some sort of prompt that says like, or it's really an instruction. It doesn't specifically have to be a prompt, but it's an instruction of the problem to solve. It's like, oh, the orders table will update, and we have to issue our hourly SEC reports. Thanks, Paul. In 10 minutes, we need to fix this thing. And so that's really all this is. And then when you run it, you say, hey, like, ADE run Jaffle 001, run this task, figure out if we can solve it. What it does is it creates a Docker container. It sticks the Jaffle project in there. It sticks the Jaffle DB database in there. It sticks a bunch of technical miscellanea that we will get into a bit in a moment. And then it says, like, hey, Claude, solve this problem. And so then we like step away from the container for a bit. Claude like gets sent out into the wilderness to try to solve the problem. It brings back whatever thing it thinks is right. And then we have to figure out if it did it right. And so the way that that works is largely through, like, there's a testing layer. That testing layer is basically DBT tests. It can be extended a little bit, but right now it is largely DBT tests. And so these can be whatever arbitrary DBT tests you want. So you can basically inspect the results that come out of the agent thing to say, like, does it do the stuff that you expected? And so these can be things like, does it get, like, the right numbers for the total number of orders? This is just like an arbitrary query to query, like, count. Do we have the right number of orders? Is it the right amount? Is it the thing we would expect if this thing ran the right stuff on top of the data set that we have? You can write, like, a bunch of weird DBT GenJ stuff to be like, does it update things to views correctly? Or does it do anything that is a part of, like, the DBT sort of model and the DAG and those kinds of things? So there's ways to basically test, like, did it work in the right way? Did it set up the right configurations? It's not just testing data. And there's some auto-generating tests that you can also have to say, like, I actually just want to test the equality of this table with an answer key that I am providing. And so the benchmark will basically generate these tests if you provide the answer keys to figure out if these things are correct or not. And so you may be like, OK, where this fact orders table, I know where that is. What is this solutions thing? You can provide a set of, like, solution keys, basically as seeds, that then get fed into the benchmark when it runs the test to say, like, does it match the data set that we expect? And so that means you don't have to do, like, the point of this is to eliminate these kinds of things where you have to basically define hard-coded values of how many rows you expect or how many orders or whatever. You can just say, I solved this problem myself. I, like, exported the CSV. There's ways to basically do shortcuts with this. And then I can stick this into the answer key and say the model should produce the same result that I got. The other thing that you have to, like, to step back a moment a little bit on this is, prior to running all these things, you can also write, like, arbitrary setup scripts. These can be things to set up the environment however you want. They can just be like dbt run or dbt deps or whatever. They can also just be arbitrary scripts to break stuff or to introduce problems. So for instance, if you want to break fact orders, you can do that, and you can have a script that's just like, OK, drop a comma so that there's now an error. Or you can, like, delete the whole thing. So in this case, you can say remove fact orders, and the prompt can be rebuild that. And it won't know what fact orders was, and you have to give it the context to say what it is. But it's basically a way to take a project and introduce some chaos into it and then say, hey, go solve the thing that I did when it can't, the agent itself can't see the chaos that you did. So you can be like, all right, delete fact orders, and it's gone. So to quickly, like, back up for a sec, like, what does all this do? How does it all work? Putting it together. There are these three things. These are, like, the main components. If you run, again, like, ADE run Joffle1, it will create this container, stick the stuff in it. It will then run this setup script of, like, breaking fact orders, and it will run dbt run, and that will fail, and they'll be like, oh my god, everything is broken. And then it will show up and say, hey, Claude, solve this problem. Stuff is broken, fix it. Claude will go off and do its thing. Then it will run dbt seed to insert your answer keys into the place, into the database after Claude is, like, basically left and said we're done. And then it will run these tests to see if it works. And then it will say either, like, dbt didn't compile. Sometimes this thing just writes terrible SQL, in which case the test fails. Sometimes some of the tests will pass and some will fail, in which case the test fails. And sometimes they all pass. And you're like, the agent did great. Great job. So that's basically how it works. There's a handful of technical things I want to go through a little bit before we get into the demo. So some of the technical miscellanea. First of all, like, agents, how does this is all Claude? Like, can you use other things? Can you use your own stuff? Like, sure. That's pretty straightforward. When you run this, you can run, like, agent Claude, or you can run agent Codex, or you can, if you run Codex, it will, like, send it off to Codex. If you want to run agent Gemini, you can do that, and it's very expensive, as you'll see in a moment. Or you can run your own thing, and, like, you can point it to custom agents, and again, the folks from Macro who are part of this project, there's some results from what they did as well, and you can do that with them. Or you can give it to your own thing if you have your own thing. You also don't have to use, the point of this is not, like, just run it against those agents. The prompt here is intended to be an instruction, and if you're like, I have a really great, like, Claude.md file that I think can help solve these things, or whatever kind of context you want to give to make this better, the point is, like, this is the instruction to have. Can you build something that solves this problem better than giving that instruction directly to whoever else? Another question people have, dbt fusion. You may have heard of this. This was popular around here. Look, it's the new dbt. Suppose you want to run dbt fusion or try this in different environments like that. You can also do that as well. You can create these different sort of variants. So that's part of this technical miscellanea. When you run it, like, the container will install dbt core. That's not how it actually works, but that's fine. You can also create different variants of this to run it in different contexts. So in this case, hey, let's point it to dbt fusion and see how it works with dbt fusion. It will then run. You can say, hey, run this with the project type dbt fusion. And the technical miscellanea will then get updated to run, like, dbt fusion. And this is, like, kind of stylistic, because that won't work. But, like, kind of the same idea. OK, so that's cool. So you can run it with different, like, kinds of dbt. Some people may be like, I'm skeptical of that. Because this is the databases that dbt fusion currently supports. DuckDB is not on there, so it's like, that doesn't work. We've got to do this with Snowflake. So you can also point it to Snowflake. You may be skeptical of that pointing it to Snowflake because like there is no joffle.snowflake file. That is not how that works. So it also supports different databases. And the way that works, if we go through the databases, is in this sort of similar call, you can say like run it off against a particular database. And what that will do is it will create like a database environment for this thing to test in. So for Snowflake, it will take the database that exists, it will clone it into a test environment. It will like create all the necessary permissions to give to this DBT user to be able to do it. It's basically a sandbox for it to like muck around in ways that it won't break anything. It will then basically do a bunch of grants. The grants are way longer than this because Snowflake grants are hell. But it basically is saying, hey, this user now has permission to do this stuff. And then it will update all the DBT parameters to be like, all right, the profile has the right configuration and all that sort of stuff. And of course, you may be like, I'm still skeptical of that because like, where the hell does this come from? I had a DuckDB database. How do I get this into Snowflake? That doesn't work, but you can get it there's like this migrate command and ADE-bench that you can do to run basically move DuckDB databases into Snowflake databases. And so if you have something you ship in DuckDB, we can just run it off on Snowflake. You may also be skeptical of that because you're like, these things don't actually work. The SQL doesn't match. So DBT Fusion will solve that problem for us, but until then, you can also have like migration scripts that will help you migrate projects to different like syntax and things like that. And so there's all this stuff is just set up basically to be able to make it really easy to build these tests and to migrate them into different environments and test them in different contexts with different agents and different like DBT environments against different databases in whatever kind of world you want. So to like explain all this for a moment, right before the demo, I was like, why does all this exist? What is the point of all this? Like that was kind of complicated and messy. The reason for all of this and the reason there's like some complication here is the point was to create kind of as realistic of testing environments as we can, which requires having like all of these DBT projects. It can't just be a series of files. You want to basically be able to give it something that looks real, as complicated as you want it to be. And so this kind of has no real top end on how complicated it can get. Where you can create very complex testing criteria. So the point of like the tests and the seeds and these arbitrary ways to do evaluations is sometimes these things are hard to test. It's not just like, does number A match number B? There's a lot of things you potentially want to be able to evaluate, and so you can create whatever test you want. That can be done with like through simple files. So a big part of this that's also hard is if people have like a Snowflake database, you can't share that. And so being able to package these up in something like DuckDB, which is very shareable, is very helpful. There are some ways to like do some like data anonymization and things like that, or it's also just like open source stuff. But these can be packaged up just into files, but you also want them to be able to be replicated in like truer production environments like Snowflake. And so that's the point of some of these migrations. And then also, you want to be able to create multiple tests on the same environment. The hardest part of this is actually building these environments that look real. And it's annoying not to be able to like use those across multiple tests. And so that's what this setup thing is for, and why you can do sort of multiple tests in one environment, is it makes it very easy to say, hey, I have a DBT project like Joffle. I can come up with 50 different things that are like tests that might be the types of problems I have. And so I want to be able to create all of those, and there's very straightforward ways to do that. So that's like basically what it is. Real quick then, moving on, a demo and some early results. Before the early results, I should emphasize these are very early. This was like me running this on my laptop in the middle of the night last night. Are they entirely accurate? I mean, like they're vibey. But they represent something, and we'll make them better. OK, so this is how it works. So this is Snowflake with Claude 4.5 on top of DBT Core. The current pass rate of this thing, which on its own I would not put too much stock into, like this is the test that we have created. Whether or not that's high or low, it doesn't really matter. The point is like how it does relative to other things. I was talking to someone last night. It's like the first person who ever took the SAT. If they got a 600, is that good? Nobody knows. But the point is to figure out like how is that relative to other stuff. So this is how it is. It costs like $13 to run it across all the tasks. It takes an aggregate of 162 minutes to solve it. If you run it on DBT Fusion instead, it's way faster and cheaper. Shout out DBT Fusion. This is also not how much it costs to run it in Snowflake. This is the cost of like Claude running. So for whatever reason, DBT Fusion is easier for Claude to figure out, and it can do it in smarter ways. If you add an MCP server, so DBT supports an MCP server, you may notice this, it actually gets a good bit better at solving this problem. And so Claude 4.5 can solve half of these problems, slightly more expensive, but faster using DBT's MCP server. Other agents, so to test it against the bad stuff, wanted to see how it did against like the old Claude models. Not nearly as good. It's way cheaper if you want to deliver yourself terrible numbers cheaply and not that quickly, I would recommend 3.5. Codex also has an agent like this. It's pretty cheap. This is this is very vibey. Codex does not report actual numbers. You have to kind of estimate this off of like tokens in and out. And so I don't know how much stock I put in that number, but it does seem like to be reasonably cheap. And I have not blown through like my Codex tokens nearly as quickly as I would have thought. So it seems like it's actually pretty cheap and reasonably performant. I tried to run it against Gemini. It was very expensive. Would not recommend at the moment. Maybe it was me doing something wrong. I don't know. Gemini was like solving each one of these things. It costs like $10 per problem. So it like seems to spiral itself into little holes, and I don't know why. Anyway, that's why this exists. Also ran some against DuckDB as a baseline. So for instance, some things do not support, like you can't use Snowflake for them. So against DuckDB, it does a little bit better. I don't know why this is. This was like sort of a curious thing to me. It can actually interact more directly with the database, and it can like basically write its own queries faster and stuff like that. So that would be my hypothesis as to why it did it. But currently, it's a little bit more performant against DuckDB. And then Macro, the folks again who are involved in this, and you should all check out, basically performing on slightly the same level as Claude, a good bit faster. So they have built a bunch of things to actually like try to solve these problems faster and a little bit cheaper. Doesn't come out cheaper yet, but like it does come out faster than all these other things in how they're actually solving it. So, like I said, I don't know, are these results right? We'll figure it out, and we'll do more later, and we'll get like a much larger set. But this is how it looks today, and this is the kind of stuff that we can try to figure out. All right, I have like 8 minutes left. We're going to attempt to do a very quick demo. Let's see how this goes. All right, let's try. Ooh. Mirror. Cool. All right. This is the thing. OK, so real quick, that's the commands I'm going to have to run. So this is a prompt. This is a task. This is like the more involved version of a task. You can basically see this is the prompt. So it's basically saying, hey, there is a set of models you need to create. Go create these models in this config file. So basically, there is a config file that has tables and columns, and it's saying, please go create these models so they fit that config file. So you could actually imagine doing like development in this sort of way, where you are just writing configs and description of columns and saying, go build this thing. And it's a test of whether or not it can do that. And you can see the way this actually gets set up in here is these models actually already existed. And so when you run this test, the setup script just removes them all. So it like wipes out those models, and it's saying, hey, go recreate them. The agent is not aware that these existed, and so it has to try to solve them on its own. And then the tests are things like, these are the models. Do they actually, these are autos, or because they're automatically generated, do they equal the thing we expect them to equal with these answer keys? So that's one type of task. Another task is this, the same, this is on top of like an F1 data set, which is not, most of these are like real businessy data sets, but this one's a little more fun. This one is basically saying there's a problem in the data, that some columns are showing as zeros. I don't think they should be zeros. Why is that? Like, this is a little bit more representative of the types of problems we have. It's like, there's a bug. Somebody is upset that the table is wrong. Can you fix it? And so in this case, the way this gets set up is actually it's like changing a bunch of like case statements to use lowercase instead of uppercase, or uppercase instead of lowercase. I don't remember which. It's basically making this mismatch in a case statement so that like these things evaluate to being false. So when you run this, I will attempt to run it, and then I'll show you the results because it takes a minute. So this is, you can, oh my God. Well, check out my very Spartan terminal. So the way this works is it's just a command line thing. You can kind of see, look, it's going to do stuff. These are some of the commands you can run to run this. This is basically like you interact with it as a command line tool. If I want to look at the tasks that are currently available, oops, tasks lists. These are all the tasks that are in there. So it's got some commands like this to basically be able to interact with it and play around with it and understand what's going on. These are the tasks that are currently supported through this, the ones that we have built. But the real thing I probably want to do is like run it. And I will show you what it looks like to run, and then I'll show you the results. And then we'll be done. All right. So here, I'm going to run this. So you can see what this is doing. Maybe, let me move it up. It's saying, all right, ADE run on these two tasks, so F1002 and F1004, the one I just showed you. Run it against on Fusion, run it against Snowflake, use Codex, and use MCP. And so it's going to basically create the environment that sets up an MCP server, that connects it to Snowflake, that sets up dbt Fusion, and then gives it these prompts that you just saw and say, can you solve it? So if I run it, this thing will now kick off some stuff. It's going to build these containers and go do its thing, and you'll see this stuff start to tick its way through some things, which we will ignore for the moment because it takes a moment because Codex has to think. But we have some results that I can show you of what this looked like. Where is it? Here we go. When it gets done, it will generate like an HTML page of the results. This is an example of what those look like. I ran this morning for these two tasks. You can see it passed one and it failed on another. If you want to look at how it did, you can say, like, these are basically the logs from the thing. Here is Codex doing a whole bunch of shit. This is like the Codex logs of what it's thinking. If you look at the very end, you will see here, it basically says, look, I finished creating this driver-centric aggregate models that satisfy the __ stats.yaml config. It did all the things. And then this is the part where it runs the tests, which is basically saying, OK, it's going to run dbt run. Here is some Fusion output. It seeds the tables with these solution seeds. You can see that here. And then it runs the various tests that evaluate whether or not they match or not. And they all passed. And so great. So the test passed. The more interesting one, though, is actually this one. This is the one that failed. This is the problem where it like changed the case of various case statements. And so we want to look at what it did. We can be like, OK, look through, here's all the stuff. You can see it's making these various calls to like the dbt MCP server here. So it's like checking some stuff and trying to solve this problem of like what's going on with these things not matching. And then you can go down here and be like, all right, I finished this problem. I reclassified the strings. It actually mostly figured it out. The problem is these stores are in lowercase, and the old title, cross-case comparisons, returns 0 for every driver. Like, good job, Claude or Codex. You figured this thing out. However, why did you fail? The other thing that this will record is diffs. It will record the diffs of the things that the agents did. If I look at the diffs of this, I can look at the things that the agent modified. The weird thing that it did, you can see, like, look, it made the right corrections at lowercase, lowercase, lowercase. It actually did a thing that was smart, which was one of the other things that got introduced in this is it changed unclassified to not classified. Like it wasn't just a casing problem, it was also a name problem. It figured that out too, which is impressive because that means it had to actually inspect that is not in the DBT file, that is in the database itself. So Codex actually went and inspected the tables and realized that's what it needs to be. But for some reason, it changed the position description from withdrawal to status description. Like, why did it change this from position description to status description? I have no idea. It shouldn't have done that. And that's why this failed, is because it got most of this stuff right, but for whatever reason, it introduced like a weird change to use a different column for no reason that was requested, but it got confused by something, and so it broke it and failed. So that's what it does. And so you would do this like over and over and over again for all of these tasks and see how it does. If we do this, we can see it is now calling the agent, and we're waiting on Codex to come back, and whether it'll solve this or not, I don't know. We can check at the end of this in 0 minutes. OK, to finish up then, real quick, the last thing. What do we got? We'll just go here. There's still more slides. All right, watch what happens live. How people can help. If you all want to be involved, that would be great. There are ways you can help. One is there's a GitHub of this. Don't read the commit messages. It's there. It'll probably move at some point. This is where it is now, where it's like this is a temporary spot. Also, if you want to help, perhaps you want to follow along. Perhaps you want to contribute to the testing framework, like the way that the benchmark runs. That would be great. Perhaps you would like to contribute tasks or DBT projects. That would be even better. Maybe you work at a company that wants to use this to help evaluate your product, and you'd like to run and see how like your thing does against something like this. Great. We'd love to talk. Maybe you want to create internal tests because you're trying to evaluate all of the vendors that are selling these things. It is also built a little bit for that use case where you could take it and plug it into your own problems and see if these solve these problems. Perhaps you would like to pay money for somebody to do this. Also would be wonderful. You can go here to this old fucking 80s ass Bitly link. This is where this survey is. You can answer these questions and others on a survey. And so I will stop there. These are the links from GitHub and then from like 2008 Bitly. For this thing to fill out a survey if you want to be involved. I am 42 seconds over time. I will stop. If you have questions, I'm happy to answer them. Go catch your flights. Two what? 2 questions. There are 0 questions. I've been working on this for, I don't know, like 6 weeks, something like that. I don't know. A lot of it was taken from Terminal Bench, shout out Terminal Bench, and then it's like been largely rewritten. And there's just a bunch of weird complications that go into like, how do you get MCP servers to talk to each other in the right way and weird sandboxes, and like, it's a whole setup of DBT packages mismatching, and it's all little things. Building the simple thing is very fast. Building all the little things is just a headache. Would not recommend. Yes.
Do you envision extensions of this with to test with like the semantic layer involved?
Yes.
Right? Or like with extra semantic metadata, like the diff of like how better it does when there is semantic metadata.
Yeah. And so there are things like semantic layers, or you could also add just like documentation to the environments. All that stuff is just fed into the container that then the agent has access to. So being able to have that is great. That's a place where having access to that is hard. There are not open source repos full of like good or even just bad and like messy documentation. And so that's the place where this is honestly needs the most work, is getting access to stuff like that. So if you have DBT projects that you no longer use that you would like to donate to a good cause, please fill out this survey on your Nokia. Yes.
Thank you. This is really great. It's actually interesting that even the labs say that if you want us to make progress in your industry, you should provide a benchmark. So I think that's a pretty cool endeavor. How do we add our own agent there? So we need to provide a command line interface, or how do we do that?
So right now, basically, it creates a container, and whatever you want to do to interact with that container is the way to try to do that. That could be a command line thing. It could be something that you install in that. It could be like there are APIs that it's just making calls to. If your thing is a website that you have to point and click buttons, that's difficult, though it's possible to basically use these things and put them somewhere where that can connect to it. And if you have automations on your side to basically run against, like, you essentially just have to give it the context in these buckets. And so this will create containers for you. If you just want to create your own and point your website to it, that can work. But right now, the thing that it does is it will create a container with all the pieces in it. And like, if you want to have access to that, you can probably just set up ways to access that container directly.
Okay, that makes sense.
So yeah, that's like, depends on how you do it, but it's not as straightforward as something that's more command line or API based. Yeah.
Given what you've seen doing this, how close do you feel like we are to just not needing humans to do DBT?
Not close.
No?
Like, what the hell did it do? Why did it change that column? Like, there's a lot of that stuff that it can do a lot of things. Like, the prompt before was create 4 models. And they're not straightforward. They're things that aren't just like select star from tables. They're models that require aggregation and require like understanding how these things work. Some of these tests are things like create an NPS score. And it doesn't actually give any definition of what that means and things like that. And it does it pretty well. But it's when if for whatever reason, there's a lot of these things like this that happen, or it will change weird stuff. It will confuse itself on some strange ways. It figured out like the thing of this column doesn't actually say the thing it's supposed to say, but like, why does it? It seems like it has this inclination, and you'd see this in engineering stuff, where it like really wants to create more tests and write better documentation and be like aggressively putting in like ways to solve edge cases. And so it seems like it tries to do a lot of that, and it's like, please don't. And that may just be a thing where it's like, write a better prompt. But right now, that's like where these things are instructions and not prompts. Yeah.
Firstly, thank you. This is an awesome job. The other thing that I wanted to ask is, like all benchmarks, of course, this task has a remarkable feature of knowing what the right answer is and being able to iterate until it hits that right answer. Does the structure of the ADE benchmark allow for like messy answer searching, like answers hidden somewhere in the complicated prompt, somewhere in the SEC filings from 2 months ago, stuff like that?
There are a handful of things that, some of the questions are questions that require like external knowledge. If you look, this thing finished. It got both of them right this time. Good job. If you look at this at the very bottom, there's a tag here that is external knowledge, I think, that does exactly that. That basically requires it to have some understanding of something that is not anywhere in this. So you can do those sorts of things. There are also ways to have multiple answers to a problem. So if you want to say, like, there's 3 or 4 valid ways to do this, we'll accept all of them. You can give it multiple keys. The other thing is, a lot of people have asked questions about, what about analytics questions that are like vague, like what's wrong? There's a lot of ways to answer that, and it's not easy to evaluate. One of the things I was experimenting with is you actually can sort of do that through like multiple choice, honestly, where one of these F1 questions is exactly that. It's like, somebody introduced a change. Go look at this model. It was just added. What's potentially wrong with that model? And it gives you 7 or 8 things that are like, there's a bad join in there. There's a way that it blows up. There's something about the way that like the reasoning in that doesn't work. And it does some interesting stuff in those cases. This is the thing I think to figure out is how do you solve like these open-ended analytical things? Nobody's had a great job of it yet. But that's the reason why it's kind of really open-ended in what you can build on top of it. But yeah, I would love to be able to do something like that. All right, we have to leave. Thank you all.